have a solution to sac201 problem number 1. Particle number 2 of charge 1.5 times 10 to the negative 7 coulombs is 0.56 meters away from particle number 1 of charge negative 1.2 times 10 to the negative 7 coulombs. Find the force exerted on particle number 2 by particle number 1. Since we have a force being exerted on one particle by another, we can identify this as a standard Coulomb's law problem. We'll start by writing down our charges. Charge number 1, we use the symbol Q for charge. So Q1 is equal to negative 1.2 times 10 to the negative 7 coulombs. And we use the symbol negative for our charge. And we have this being 0.56 meters away from charge number 2, which is positively charged. So we're going to use a positively charged symbol there. And we make Q2 equal to 1.5 times 10 to the negative 7 coulombs. Now, we decided that this was a Coulomb's law problem, and we can find Coulomb's law from the formula sheet. And we see it here up in the upper left-hand corner. And we're going to copy this onto our problem. So we have force being equal to K times the absolute value of Q1 times Q2 over the distance between the two particles. Now we use the absolute values here because we're just using Coulomb's law to determine the magnitude. Since we know that we've got particles of opposite charges, we know that the forces are going to be exerted towards one another, so we don't need to use Coulomb's law to determine the direction. So we'll just use the absolute values to determine the magnitude, and the force will be exerted towards the other particle. So substituting our values into this equation, we get force is equal to K, which is a constant, and we can get K, the constant is on the formula sheet as well, over in the right-hand corner. And we see K here. So we have 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. And then we have our absolute value, which is the positive value of charge 1, so we're going to use 1.2 times 10 to the negative 7 coulombs times charge number 2, which is already positive, so we're just going to take the value of that as 1.5 times 10 to the negative 7 coulombs. And this is all over our distance squared, which our distance was 0.56 meters. And since it's already in meters, we don't have to think about converting because our units are the same here and here, and also the coulombs and the coulombs. Use that squared. And we find that force we want to be in newtons, so we're going to find that Coulomb squared in the denominator here is going to cancel this Coulomb and this Coulomb, and that the meters squared will be canceled by the meters squared in the denominator here. So by calculating this, we find that force is equal to 0.00052 newtons, and we determined that it's two particles that are oppositely charged, so that we will know that the force is being exerted on one another. So the force on particle number 2 is 0.0052 newtons towards particle number 1. So we'll just write that out.